All right, today we're talking about something that honestly sounds a little like science fiction. It's the story of an AI that can actually build other AIs. It's called MLE-STAR, and it's a potential game changer. So just imagine for a second, what if instead of spending months coding and experimenting, you could build a competition-winning AI just by describing what you wanted it to do? That's the dream, right? Well, that dream is getting a whole lot closer to reality. But before we dive into how this new system works, you really have to appreciate just how hard building AI is right now. It's a tough, repetitive process that folks in the field call the machine learning grind. Yeah, creating a top-tier AI isn't about waving a magic wand. It's this grueling, super hands-on process. It takes a ton of manual labor, endless experimentation, and just a whole lot of trial and error by some very smart human engineers. I mean, just look at the typical path. An engineer has to figure out the task, wrestle with the data, try to pick the right model, and then they get trapped in this brutal cycle of endless experiments, tuning, and debugging code. It's a complex loop that can go on for weeks, sometimes even months. So naturally, people thought, hey, let's use AI to help with this grind. AI assistants, powered by large language models, came onto the scene to try and automate things. A fantastic idea, in theory. But those early versions, they had a pretty major blind spot. And here was the problem. These first-generation agents were basically stuck with what they already knew from their training data. So they'd often default to older, more common models, completely missing out on the latest and greatest cutting-edge solutions. And you can see that problem crystal clear right here. A typical AI agent, that's the blue bar, just keeps going back to models like ResNet. Now, ResNet's a solid model, but it's from 2015. In the AI world, that's ancient history. Meanwhile, MLE-STAR in red is out there actively finding and using much newer, way more powerful models. That's the difference. So, to fix this problem, to break AI out of this rut, researchers at Google developed a totally new kind of agent, and that's how a star was born. Meet MLE-STAR. And that star in the name isn't just for show. It's an acronym that stands for its two secret weapons: web search and targeted refinement. So instead of just guessing, it actively searches the internet for the best tools, and then it intelligently refines its own code. And hey, don't just take my word for it. The researchers who built it said it best. It doesn't just rely on memory. It starts by doing its homework. It searches the web to build a really solid foundation before it even thinks about writing code. So that all sounds great, but how does it actually work under the hood? Let's take a look at the master plan for building a winning AI from scratch. The process is actually pretty elegant. First, it hits the web to find some good candidate models. Then, and this is the really clever bit, it runs tests on its own code to figure out which single part has the biggest impact. Finally, it zooms in and focuses all of its effort on making just that one specific piece of code better. Right, but that leads to the million-dollar question, doesn't it? How on earth does it know precisely which part of the code is the weak link? Is it the data prep, the model itself? How does it figure that out? Well, the answer is a classic scientific method called an ablation study. You can think of it like the AI is playing detective with its own code. It methodically turns off one component, sees what happens, turns it back on, and tries another. This lets it pinpoint the one part that's making the biggest difference. The best way to think about it is like a chef. A great chef doesn't throw out the whole soup if it tastes a little off. No way. They taste it and they know, aha, just needs a pinch more salt. That is exactly what MLE-STAR does. It finds the one single ingredient that needs adjusting, which is so much smarter than rewriting the entire recipe. But wait, it actually gets even smarter. MLE-STAR has these built-in checkers that act like a little quality control squad. They're programmed to automatically hunt for common but really critical errors, the kind of stuff that even human experts can miss, like bugs or the infamous data leakage. For example, in one of its tests, a checker found a data leakage bug. That's where the model basically cheats by looking at the answers, the test data, while it's still training. That is a huge no-no in machine learning. The checker spotted the mistake, rewrote the code on the spot, and made sure the final model was robust and, playing fair. Okay, so the theory is impressive, but does this thing actually work in the real world? Well, to prove it, the researchers threw it into the ultimate test, the world of competitive Kaggle challenges. We're talking about the AI Olympics here. And the results were, frankly, stunning. In these high-stakes competitions, MLE-STAR walked away with a medal nearly 64% of the time. Now, to be clear, winning a medal on Kaggle means you are performing at a level that beats the vast majority of human experts. And if you want to see just how big of a deal that is, look at this chart. The old-school agent, in blue, got a medal less than 26% of the time. MLE-STAR more than doubled that rate. This isn't just a small step forward. It's a massive, massive leap in what an automated system can do. In fact, it doesn't just beat other AIs. The researchers found it even performs better than systems that rely on a person going and manually gathering winning strategies from old competitions. This thing is a genuinely top-tier competitor, all on its own. So let's zoom out for a second and think about the big picture here. Because a tool this powerful, well, it has some pretty incredible implications for the future of, well, everything. So what does this all mean for us? Well, for one, it dramatically lowers the barrier to entry. This could spark a wave of innovation everywhere, from healthcare to climate science. And since it learns from the web, it's a system that just gets better and better as we humans keep innovating. It could turn projects that take months of grinding into something you get done in a few days. And all of this leads to one final, really mind-bending thought. We are officially at the point where an AI can build other, powerful AIs completely on its own. So the only question that's left is, what are we going to ask them to build next?